Good afternoon. We are going to learn about how to do rotations today. This is Chapter 3, Section 3A, the first part. And we're going to learn how to physically draw a rotation, also how to do a rotation point to point. And then we're going to learn some of the special formulas that go with rotation. Okay, so first off, how to draw a rotation. First bullet, draw a line from the center of rotation to a vertex on the graph. Step 2, use a protractor to measure the correct angle of rotation and draw a rotation line to show where the new vertex will be. Third, measure the distance from the original vertex to the center of rotation and mark off an equal distance on the rotation line, and then mark your new point using primes. Okay, so let's use this little picture here to kind of get an idea of what we're talking about. In this picture, the center of rotation is marked here, and we're going to call that C for the center of rotation, and then you've got point A. So if we wanted to do, let's say, a 90-degree rotation, and we're going to do it counterclockwise. Counterclockwise, which is not the default. So if they say counterclockwise, they really do mean in the opposite direction as a clock. So following the steps, draw a line from the center of rotation to the vertex on the graph. So I'm going to draw a line from C to vertex A. Then we would use a protractor to measure the angle of rotation. So I would line up my protractor with the center of rotation here and the line drawn to A on the baseline bar. I would find 90, make a mark, and I would draw a line of rotation. And that's using my protractor. Okay, and then the third step is you measure the distance from the original vertex to the center of rotation. All right, let's count. 1, 2, 3. The distance is 3. And then we're going to measure the same distance along our rotated line. So we're going to go up 1, 2, 3. I'm following that line, which means that here is my new point. So if this one is point A, this one is point A prime. All right, those are the basic steps. Now let's try it with a figure that's floating in space. We are going to draw a 70-degree rotation of triangle XYZ about point P. And the word about is how you know that point P is your center of rotation. Now, really, really important, if it does not specify counterclockwise, your default direction is always clockwise, which is the way the clock goes, this way. So that's really, really important because you want to make sure you're going in the right direction. Since this doesn't say counterclockwise, we assume clockwise. Okay, so let's start with X, and I'm going to use a pencil. This is our original figure. I'm going to use a pencil so that we can see the figure versus the lines. And this does get a little messy, and that's okay. So draw a line from X to the point of rotation. Now I need to go 70 degrees clockwise, so I'm going this way. So I'm going to line up my protractor so the hole is on the center of rotation. Line up your baseline with the line we just drew. My 0 is on the outside, and I'm going to make a mark at the 70. Take your straight edge and draw a line. And you don't have to make it huge. It just needs to be long enough that you can measure the X. All right, so now we're going to measure how far is X from the point of rotation. It is 4 centimeters. So we're going to measure 4 centimeters along the line that we just drew. Right there. That is our X prime, our new X. And it's been rotated 70 degrees. Okay, so now we're going to do Z. So draw a line from Z to the point of rotation, the center of rotation. I have to turn this a little bit. So we're going to mark a 70-degree rotation. So we line that up. 70 is here. Draw your line. And now we're going to measure from Z to the center of rotation P. It is about 5 centimeters and 2/10. So we're going to measure that far, 5 centimeters and 2/10 is right there. That is your Z prime. All right, last one is the Y. So we're going to draw a line from Y to the center of rotation. And again, you might want to turn this so you can measure a little easier. We're going to put the baseline on our PY line. Measure 70, make a mark. Draw a line from P through your 70 mark. Okay, so now we need to measure from P to Y. It is 2 centimeters and looks like 7/10. So we're going to measure 2 centimeters and 7/10, which is Y prime. Now the real test is if you draw lines between the vertices, does it look like the original? No, it's not too bad. So that is how you do a rotation in floating space using your protractor. Flip the page. Okay, so we're going to get into some notation. Like all transformations, there are ways to write rotations so we can be clear. Here's the basics. A rotation of x degrees about point P, it's a lowercase r, and then in the subscript, you have the angle of rotation, x degrees, and then the name of the point it's going to be rotated around, which is P. That is how you write a rotation. Rotations are rigid transformations. The original shape should not change angles or side lengths. The default direction is always clockwise. Okay, so there's some specific rotations that come up more often than others. We're going to do that. And I'm going to use some colored pens so it shows up on the graph. These are specific rotations about the origin, which is many times what you're asked to do. So we're going to rotate 90 degrees about the origin. So lowercase r in the subscript 90 degrees, comma, and then an O for origin. Okay, so if we have to do this manually, let's rotate point, let's see, we're going 90 degrees. Let's rotate point K. So we're going to go K for 90 degrees. So we draw a line from K to the center of rotation, which is the origin. Then we measure 90 degrees using our protractor. Draw a guideline. And then we're going to measure the distance, which is, looks like 2 centimeters almost exactly. So 2 centimeters almost exactly. It's right here. That is your K prime. And we've rotated it 90 degrees clockwise. Now there is actually a point-to-point formula that you can also use. You might figure it out just from what's here. The point-to-point formula is you take every point x, y, and you are going to multiply the y by a -1 and keep the x the same. So in this case that we just did, point K was originally at -4, -2, and when we rotated it, K prime was at -2, +4. So the x and the y switch, and the y is multiplied by a -1. So -2, the -4 gets multiplied by a -1. Okay, that's your 90 degrees. Let's do, I'm going to change colors. Let's do 180 degrees about the origin. So lowercase r of 180 degrees around the origin. And 180 degrees is straight across, which makes it a pretty easy one to do. So let's take line L, and we're going to go straight across. So we have our original line. So 90 degrees would be, let me draw the pencil in, would be straight across from L. And if you don't have a ruler, you can also measure using squares. We go 2 left, down 1, 2, 3, 4, 5. So go 2 right and up 1, 2, 3, 4, 5. So you can also count squares to get your distance in there, and that would be L prime. Now, the point-to-point formula that goes with 180 degrees is you take every point x, y, and you just multiply them both by a negative. So negative x, negative y. Okay. 270 degrees about the origin. To rotate 270 degrees about the origin, the notation, lowercase r, going 270 degrees around the origin O. Now, you'll notice that you don't have a 270 degree measure on your protractor. It only goes up to 180. Well, all the way around to where you started from in a circle is 360. If you take 360 degrees and you subtract 270, you end up with 90 degrees. So 270 degrees clockwise is also 90 degrees counterclockwise. So we can go 90 degrees counterclockwise. So let's take, let's use L again, and we're going to go 90 degrees counterclockwise. So we already have the line drawn. So now we're going to take our protractor, and we want this to go counterclockwise. So clockwise is to the right. It'd be this direction, clockwise. So we're going to measure counterclockwise 90. So it's going to go around this way. There's our 90. So all I do is line up, get the 90 degrees, draw your rotation guideline. So again, this one is going all the way around 270 degrees. We did that by measuring 90 degrees counterclockwise. And again, you can measure distance. So you can go 1, 2, 3, 4, 5, 5 up, 2 over. So up to 1, 2, 3, 4, wait, up to 1, 2, 3, 4, 5. Boy, I kind of missed that, didn't I? And there is your point L prime. So what is the formula for the point-to-point? Take every point x, y, and switch them and multiply the x by a negative. So looking at L, we started with L, which was at -2, -5. And you switch the 2, so you've got y coming first, so -5, and you put the x but multiplied by a negative, so -5, 2. Oh, I totally blew this angle. All right. Yeah, I completely blew this angle. There we go. That's where the angle should be. So you can see why it's kind of handy to have the point-to-point. It just makes a better rotation. Okay. So we already kind of rotated some of these points. I'm not going to go through and draw the entire rotation. We've done each of the measurements. I think that about covers it. But let's practice these point-to-point formulas. They do take a little bit of getting used to. We're going to use point-to-point formulas to find J prime, K prime, L prime, M prime rotated 270 degrees about the origin. Okay, so the rule for 270, you take every point x, y, switch them, and multiply the x by a negative. So for -7, -2, we're going to switch them. So -2 comes first, -7 comes second, and then multiply -7 by a -1. That gives us -2, 7. Okay, let's do k. Switch the x and the y, so -2 comes first, -4 comes second, multiply the -4 by a -1, and our rotated point is at -2, 4. Okay, L. Switch the x and the y, so -5 comes first, -2 comes second, multiply the new y by a -1, and you get -5, +2. Last one. Switch the x and the y, so -5 comes first, -9 comes second, multiply your new y by a -1, and you get -5, +9. So those are your point-to-point formulas for rotating points 270 degrees clockwise about the origin. All right, that's it for the day. Have a good afternoon.